All right, guys, so here's page 5 of your review. Okay, so on this one, we have a function, and we want to find the equation of a tangent line, okay, at the point where x equals 1. So we should know how to do this. Remember, for the equation of a tangent line, we need a point, we need a slope. So the point that they gave me was x equals 1, which means I need to find the y value. That means I need to find f of 1. Basically, that means plug in 1 into all the x values in f. So this is going to be 2 times 1 minus 1 to the 5th power times 1 plus 1, which is going to be 2 times 1 is 2, 2 minus 1 is 1, 1 to the 5th is still 1, and then 1 plus 1 is 2. So 1 times 2 is 2. So my point is 1 comma 2. Now the slope is just a derivative. This is a derivative. So if I look at the derivative of f of x, I notice that I have two things happening here. They're being multiplied. That means I need to use the product rule. Okay, so let's go ahead and find f prime of x. Okay, so this one's kind of a lot on this one. So it's the derivative of the first, okay? In here I have a chain rule. So I'm going to take the little 5, move it to the front. So it's going to be 5 times 2x minus 1. My new exponent is going to be a 4, but then I still have to multiply by the derivative of 2x minus 1, which is 2. There's your chain rule. So that's the derivative of the first. Then I have to multiply this all by the second. The second function is this x plus 1. And then plus the first, which is 2x minus 1 to the 5th, times the derivative of the second. The derivative of x plus 1 is just 1. Okay, now you guys, I like to clean up before I plug things in, so let's go ahead and do that. What can I multiply together here? You guys, this 5 and the 2 can be multiplied together. So I know 5 times 2 is 10. Then I have this 2x minus 1 to the 4th times x plus 1. And 2x minus 1 to the 5th times 1 is just 2x minus 1 to the 5th. Okay, but I don't want the equation for the derivative. I want the value of the derivative at x equals 1, right? Everything is happening at x equals 1. So if I plug in a 1 here, it's going to be 10 times 2 times 1 minus 1 to the 4th times 1 plus 1 plus 2 times 1 minus 1 to the 5th. Okay, so that'll be 10 times 2 times 1 is 2, 2 minus 1 is 1, 1 to the 4th is 1, 1 plus 1 is 2. Again, 2 times 1 is 1, 2, 2 minus 1 is 1, 1 to the 5th is 1. So this is going to be, let's see, it's 20 plus 1, which is 21. So here's my point, here's my slope. So the equation is going to be y minus 2 equals m, which is 21, x minus 1. Now look, if I look at this, I'm like, hey, none of those are my answers. Okay, so it's got to be between a and b because those both have a slope of 21. Okay, so in this rare case, they actually did solve for y, so let's go ahead and do it. So this would be y minus 2. If I distribute the 21, 21x minus 21. And then if I add 2 to both sides, negative 21 plus 2 is negative 19. So this would be y equals 21x minus 19. So the answer is B. All right, number 16. What is the slope of the line tangent to the graph of? Now, you guys, a lot of people, when they see tangent line or line tangent, they start doing point slope. But look, that's not what they're asking for here. They're just asking for what is its slope? Slope is just a fancy way of saying derivative. So don't do more work than you need to, okay? So I just want the derivative of this at x equals 1. So I need to do quotient rule. So the y prime is going to be low d high, so the derivative e to the negative x is negative e to the negative x times negative 1, right? Because the derivative of negative x is negative 1. So it's low d high minus high d low, derivative of the low is just a 1, all over, square the bottom, and away we go. And again, you guys, do a little bit cleanup before you actually plug it in. Okay, so I noticed like on the first one, I'm going to put the e to the negative first. Look, all these guys are getting multiplied together, right? I'm going to put the negative 1 in the front. So it's going to be negative e to the negative x times x plus 1. And then minus, I don't really need that one. That's irrelevant. E to the negative x all over x plus 1 squared. Okay, and now it says plug in x equals 1. So let's go ahead and do that. That would be negative e to the negative 1 times 1 plus 1 minus e to the negative 1 all over 1 plus 1 squared. Let's clean this up a little bit. So it's negative e to the negative 1 times 2 minus e to the negative 1 all over 1 plus 1 is 2. 2 squared is 4. So I'm seeing a 4 on the bottom, which probably means it's not going to be these guys, right? So you can start eliminating. Okay, and then you guys, a better way to write this, you can write this as negative 2e to the negative 1 minus e to the negative 1 over 4. And notice that these are like terms, right? E to the negative 1, e to the negative 1. So negative 2 minus 1 e to the negative 1. So negative 2 minus 1 is really negative 3 e to the negative 1 over 4. Okay, and then you guys, I noticed that all my e's are positive in my answers, so that just meant they took this and put it down below. So this is really negative 3 over 4 e to the first, or just e. Okay, so that's why it's answer B. All right, this one, number 17. You guys, when you see these, you should go, okay, these are the easy ones. You look at this, and you're basically say, okay, what's my function? The function is e to the x. And I want to find, right, what you're looking for is you're looking for the derivative at 2 because they actually plugged in a value here. So what's the derivative of that? The derivative of e to the x is e to the x. The derivative at 2, if I plug in a 2, is just e squared. So the answer is D. All right, number 18 is a really good implicit differentiation one at a point, so you have to evaluate. And you guys, look, if you're watching all these videos and you haven't done these problems yet, maybe try this one on your own. See if you can do it, because you should be able to do something like this. Okay, so when I look at the first thing, I see product rule, okay? So the derivative of the first is 2x times the second is y, plus the first is x squared, times the derivative of the second, the derivative of y is dy dx, and then minus the derivative of 3x is 3. The derivative of y cubed is 3y squared dy dx. And then the derivative of minus 3 is just 0. Notice every time I derived a y, I tagged on that dy dx. Okay, now solving for the dy dx's, so I'm going to keep this x squared dy dx on this side. I'm going to go ahead and subtract this guy over, so that's minus 3y squared dy dx. So now this guy's gone, right, equals, and I'm going to move this to the other side, so it's going to be negative 2xy. That's gone. I'm going to move this to the other side, so it's going to be plus 3. Now that guy's gone, okay? And then dy dx is going to equal negative 2xy plus 3 all over this x squared minus 3y squared. Okay, so I just found the derivative, but I need to plug in the points x equals negative 1 and y equals 2. So let's go ahead and do that. So it's going to be negative 2 times x is negative 1, y is 2, plus 3 all over x is negative 1, but it's getting squared, minus 3 times y is 2 squared. And you guys, like, be really careful that you're actually putting the x in for the x and the y in for the y. It's really easy to mix them up. I do it all the time. All right, this right here is going to be 4. 4 plus 3 all over negative 1 squared is 1. This is 4 times 3 is 12, but it's a negative, so this is going to be 7 over negative 11, or A. All right, let's look at this one. For the functions f and g are differentiable. Okay, you guys, look this right here. This is a fancy way of saying what? Do you remember that? That f and g are inverses, right? Okay, so in this case, they didn't tell you they were inverses, but they used the definition of inverse that we went over in class. So you want to make sure that you know that. Okay, so how do we do this? We could make our little table. So we're going to go f of x. There's your function. The inverse of f of x is g of x. So we're going to put g of x there. And then we're going to do a point, and then we're going to do a derivative of f and a derivative of g. And we're just going to start filling things in and see if we can get them to work out. So the first thing I see here is I have a point on f. The point on f is 3, 8. So let's put that in. That means my point on g is 8, 3. Okay, I'm going to drop in my x values. And then what's f prime of 3? Oh, they told me f prime of 3 is 9. That means g prime of 8 is the reciprocal, which is 1/9. Okay, now what are the questions? They're saying, what is g of 8? This is saying when x is 8, what is the y value of g? Well, here's g, right? When x is 8, the y value is 3, so g of 8 is 3, which which immediately gets rid of these guys, right? And then g prime of 8, well, there it is. It's 1/9. G prime of 8 is 1/9, therefore giving you the answer E. All right, look, another implicit differentiation. Oh my goodness. Okay, so let's do it. The derivative of y squared is 2y, tag on that dy dx. Okay, minus, okay, and then I have this 2, and then I'm going to go ahead and do a little bracket here. Now, this right here, again, is going to be product rule. You know what I just noticed, you guys? I just did 2 pages at a time. That's okay. It's no big deal. All right, minus 2 times. Now, the derivative of the first. The derivative of x squared is 2x times the second, which is y, plus the first, which is x squared, times the derivative of the second. The derivative of y is dy dx. And then that equals the derivative of 8 is 0. Now, you guys notice something. Whenever you have a subtraction sign followed by a product rule, I would put like massive brackets around it because you're going to have to distribute not only that 2, but that -2. This is where people mess up, and I guarantee you'll see that again on the AP test or on your test, okay? So here we go. We have 2y dy dx, and then minus -2 times 2xy is negative 4xy. -2 times x squared is negative 2x squared dy dx. And that equals 0. Okay, so I'm going to keep my dy dx's where they are. So I have 2y dy dx minus 2x squared dy dx. I want my dy dx's together, but I don't want this guy there, so I'm going to move it to the other side. It doesn't have a dy dx. It has no business being with the dy dx's. So I'm going to move it to the right as a positive 4xy. And then if I factor out the dy dx, I'm going to get that this is 4xy all over this 2y minus 2x squared. Okay, now looking at my answers, like none of them really match. Okay, so what I notice here, I'm going to try to reduce this a little bit. There's a number that goes into all 3 of these. And you guys, you can only do this if there exists a number that goes into all 3 of them. The numbers that go into all 3 of those is a 2. So I'm going to divide everything that I highlighted in blue by 2. So 4 divided by 2 is 2. So it's going to give me 2xy. Then 2 divided by 2, well, that's just 1. So it's just a y. And then 2 divided by 2 is also just a 1. So it's all over x squared. So it's 2xy over y minus x squared, which is b. All right, now 21, kind of a silly little question, but it becomes important later, okay? And the reason why it's in this unit is because this is the unit we started to talk about e's and ln's a lot more. So it's saying how many zeros does f of x equals e to the sine of x have on the closed interval 0 to 2 pi? Okay, what this is actually asking, okay, is if I set e to the sine of x equal to 0, how many places would it actually equal to 0? Now, you guys, what we need to go over on this is that e raised to anything, I don't care what you put on there, cannot equal 0, like ever. Okay, and here's why. Let's look at a graph of it. The graph of e to the x looks like this. Okay, kind of shoots up. It's an exponential function, right? Crosses here through 1 because e to the 0 is 1, right? Now the question is, how many zeros are there? Another way of saying that is how many times does it cross the x-axis? You guys notice this is going to get really, really close to the x-axis, but it's never going to hit it. That's because the x-axis is an asymptote. It'll never, ever hit it, okay? So therefore, if you see like e to any power, it can never, ever equal 0. So that's why the answer is A. It doesn't have any zeros. It will never cross the x-axis. No matter what you plug in there, you can't get it equal to 0. Okay? All right, number 22, the derivative of e to the 3 ln of x. Now, there's easy way and a hard way. I will do it both ways, and then you guys can decide what's better. So I have e to the 3 ln of x, okay? If this is your y, the derivative of that would be, now this is if you don't know your ln rules, okay? The derivative of e to the something is e to that something times the derivative of that something. Well, the derivative of 3 ln of x is actually 3 times 1 over x. Now look, if you were to do it this way, I'm kind of looking at it going, well, I don't know, maybe some of the answers are right. B looks the closest, so a lot of people circle B. But you guys notice if I simplify this, there's a 3 e to the 3 ln of x, and my denominator is an x. You guys look, these two are not the same, okay? That has a 3 in front, the other one doesn't, but a lot of people do pick B on this one. Now the question is like, how can I simplify it? How could I have simplified it before to even make this easier? So remember, let's try this again. Here's another way. You have y equals y equals e to the 3 ln of x. You guys remember this little 3 actually was up here and it flew down and like sat there in front of that ln, right? So I can bring it back up. So I can rewrite this as e to the ln of x cubed. Now e and ln cancel out, so my y is actually x cubed. Now it's really easy to find that derivative, which is just 3x squared. Okay, that's why it's d. Now you might be thinking, but isn't this way right too? It is, but you'd have to know that trick again. You have to take this back up, so let's look what happens. So this would end up being 3e to the ln of x cubed all over x, right? E to the ln cancel out. That ends up being 3x cubed over x, which is still, again, 3x squared. Okay, but again, you guys, this way was so much easier. All right, I'll stop the video because I did 2 pages. I apologize for that.